Hello, my name is Jan Finney, and this is Physics Lab 1 titled Charge Tape. Alright, so the purpose of this experiment is to observe two charged pieces of tape interacting with each other to determine how much excess or net charge is on one piece. This setup comes from Coulomb's law being present in and on everyday objects, including common plastic tape, and that neutral objects can be charged with ease. This includes by being rubbed, pulled apart, or by contact. Alright, so with some formulas, we can approximate the amount of excess charge on one of the pieces of tape. Force of gravity is also in effect due to the tape being suspended in the air, which I'll show in a slide. And over here we have the electric force calculated formula, as well as the K constant, K being 9 times 9 to the 9, as well as the charge of an electron/proton. And then this D over here is to explain the distance between the two pieces of tape. I treat them both as point charges. All right, so since the pieces of tape are tangible and large, for this experiment we need to treat them as a point charge for easier calculations. Both pieces of tape are created with the same method, where it was quickly ripped off a controlled surface, that being a clean piece of tape. For that, they must have the same charge and will repel each other. And for the experiment, two identical pieces of charged tape were created. Tape A is held in the user's hands while tape B is hanging on two chair backs. As we brought tape A to tape B, at a certain distance, tape B began to repel itself from tape A. And these were all my initial values, and the separate distance when tape B started to move was 0.01 meters apart. And these are the two free body diagrams. On the left is just the force of tape B being acting on itself. The green arrow is the force of gravity, and the blue arrow is the normal force. And on this, on the right is when we bring the two pieces of tape together. The blue line is tape A, and the red line is tape B. The blue arrow represents the direction of where it's trying to go, being repelled, and yellow is the force of gravity. All right, and this is on my glow script code right here, trying to get the calculations of the charge of the tape and the net charge of the tape as well. And these are my results. So the charge of the piece of tape were in fact to be positive. I found this out by bringing the charge pen thing together, and when I brought the charge pen to the neutral piece of tape, it actually attracted to each other, and charge pens tend to be negatively charged, which means the tape was positive. For the tape to float, the net force had to equal 0, meaning the electric force on tape B equal to the force of gravity acting on tape B. So you set those two equations together, that's how you find Q, which is the charge of the tape. And after doing that, the charge of the tape was actually found to be 5 times 10 to the negative 9th coulombs, and the tapes had a deficit of 2.7 times 10 to the 10 electrons, which is a lot of electrons. All right, so what if the protons and electrons switch charges? So in physics, we treat it as E, which E is 1.6 times 10 to the negative 19 coulombs. So with that, the magnitude of charges are the same. The only thing that would change is that we calculate for a proton deficit rather than an electron deficit. And why should we handle the charge tapes as little as possible? So back when I previously mentioned in the beginning how Coulomb's law works and how electric force can be charges can be interact with each other, is with contact, and our hands can manipulate the strength of the charged tape or the magnitude due to us having a charge of our hands, which would cause it to lose its magnitude. So in short, we were able to observe the interaction between two pieces of charged tape, as well as the relationship between electric force and the force of gravity. When you strip electrons off a piece of tape, it creates an electron deficit. Possible sources of error include contact with hands, like I mentioned earlier, humidity in the environment, the tape and distance measurements, maybe inaccurate measurements. Taking these in account for a future experiment will result in a more accurate calculation. This is my video, and thank you for watching.